And the point here is they both look exactly the same, but one contains malware and one doesn't. And you have no way of knowing or detecting that, and I'll show you why that is in a second. So let me just share my screen. Alex, I think you have to allow me to.
I've just hit the button.
Thank you. Oh, there we go. This is allowing me to now share my screen. Okay, so let's have a look at some images. Just hopefully everyone can see that. Okay, so here I have three copies of that driving license image that I was showing before. One is completely clean. One has a script steganographically encoded across the pixels of the image, and another has a script embedded in the image file that means that the file could either be used as an image file, as it is being shown here, or if I were to rename it as an HTML file, which I've done here, it can run as an HTML file and run the script that's embedded in this file. So imagine in the Know Your Customer scenario, I'm uploading a copy of a driving license. It looks and feels exactly like a driving license to any detection-based technology, and I'll show you that in a second. But actually, it's got a script embedded in it, and that doesn't have to be a script. It could be any content at all, any binary content or any other content could be appended to this image, and therefore get into your organization without being detected. So I'll just open up this image file to show you my Windows image viewer shows you the image quite happily. If I were to just close that for a second and open it with Notepad now, so let me just open that with Notepad. You'll see that if I scroll down, here's all the image data in that image, but at the top of the image, there's a script. Yeah, I'm just highlighting it for you there. So this is an example of something we call a polymorphic file. It's very easy, very trivial to create this type of file. But if I were to rename this file as an HTML file, which I've just done to save time beforehand, and now open the HTML file, you'll see that the script runs. And in this case, it's taken me to a demo site, which suggests you might have had all your files encrypted. I'm glad to say that they've not all been encrypted in this case, but I just want to illustrate the point that it's really easy to make a file that can exist in two different states. And the point here is that if I take that same file now and put it through VirusTotal, so if I go and take the image file I was just showing you and upload it to VirusTotal, you can see that there are 60-odd antivirus checkers in VirusTotal here that are saying there is nothing to detect in that file. The file I've just shown you, there was a script embedded in. And all the major vendors are here, and they're not detecting that particular type of attack. Actually, there's a whole load of sandboxes in VirusTotal as well, but none of the sandboxes run on image data. And again, that's a problem because now you're not going to have your sandbox stop this attack either. So the point here is that attackers know how to create these attacks. They know they can embed executable content in these attacks, get that content into your organization, and then they can exploit that at a later phase of an attack. So how do we stop that, and what can we do to stop it? So if I take you to Everfox's Try Now facility, this is freely available for you to try. Tryitnow.everfox.com. You can upload a file here. We will transform the file for you, create you a brand new file, and then and remove any threat that's in that file. But the point here is that we're doing that without looking for the threat, and I'll explain that in a second. So let's just take that same file that we had a second ago. Take the polymorphic file. Copy it in there. Okay, so the file's been uploaded. A new file has been created, and I can now download that file so that we can see the new file. So this is a brand new version of that image file that I've just created, and I'll show you in my downloads folder in a second. And what's happened here is that rather than try and detect the script in the file, the CDR software basically extracts the information from the image that it needs to create a new image. So we pull out the sort of pixel array here, we pull out the height and width information from the image, and then we verify we've got those things, and then if it verifies properly, we then build you a brand new image. So we've not looked for the script, we've just left the script behind because it shouldn't be there. And that's how we can defeat this type of attack without needing to detect it. So any new script, any new type of content, any erroneous content in this image data would just get left behind by our CDR process. I'll just show you that in my downloads folder. So here's the image, the new image that I downloaded. Again, I can open it, and you can see it displays perfectly happily. But this is brand new file, and if I look inside this file with Notepad, you can see that the script that I was showing you before, which was at the top of the file, has now gone. It's been left behind by that transformation process. The image data has been rewritten by us as part of that process too. So this is a really highly effective way of preventing attacks without trying to detect them. Now the problem here is that the type of attack gets even worse. I've shown you a file where if I know what I'm doing, I can look inside the file and I can see the attack content in that file. Actually, attackers can encode the binary content or whatever content across the pixels of an image using this technique called steganography, and that makes it even harder to detect that sort of attack. And so we need to be able to stop that type of attack too. And in our transformation process, we can disrupt the pixels of the image as we transform the file, such that if anything were encoded across them, we would defeat that type of attack as well. So we're stopping these advanced threats through polymorphs and through steganographic files using the process of transformation. Okay, so I'm going to hand back to Alex now to talk about how we can deploy this on top of our detection-based defenses to increase the level of security you can get against this type of attack.